Good morning, good afternoon, good evening. Hi. Uh, Good to see you, man. I'm joined today. We're at Fu, the beautiful, amazing show in Montreal, Canada, and I'm joined by
Johannes
yeah.
Bechberger of SAP.
So introduce yourself so that I don't butcher it. What do you do?
I'm an JDK developer at SapMachine. I work at SAP SE, and yeah, at SapMachine we're the third biggest contributor to the OpenJDK. I mostly do nowadays profiling.
That's super important, right? Like at some point, it's functionally complete. It just needs to be fast, you know.
Yes,
Yeah.
and creating new profiles is really a lot of work. That's what I'm working like for 3 years on now at SapMachine.
Yesterday, our mutual friend Jonathan Ivanov, who I had on the show last night, he came over to me and told me the absolute, most wondrous thing I've ever heard, which is that you're using eBPF and Java. That's the kernel. For the people who don't know, that's the way that Linux provides to sort of debug the kernel. It's kind of reminds me of what's that thing from dtrace from Polaris? But it's different approach, but same deep-rooted integration in the kernel. Why do that instead of something good with your life? Why that instead of using your powers for good?
Why not? So we're in the age of exploration. So to correct you, if I may,
please.
eBPF is essentially a way where we can hook the Linux kernel. So you probably know with all your frameworks that you can say, oh, add a hook to this.
Yeah.
For the Swing developer out there, it's like adding a method listener or something, adding a click listener. But here, what we're doing, we can attach hooks to things like, oh, there's a packet incoming into my network stack, and then deal with it. And that's pretty cool. And you can use nowadays Java with it, because I started last year, almost exactly a year ago, to write the first Java library for eBPF.
So this only works on Linux, of course, right?
Yes.
Which is awesome. Where does this fit with Cilium and things like that?
So essentially, yes, you could. Cilium is like a product based on eBPF, and they are like kind of the inventors of eBPF. They pushed it into a Linux kernel, but how it fits in is that I wanted to start with the whole eBPF in Java thing because I wanted to learn eBPF.
Yeah.
And then I'm an JDK developer, so it made sense for me to see, oh, there's no Java library for this. It's really hard to work with this in Java. And I thought, like, we have now Panama with like the foreign function interface, which one of my colleagues implemented on PowerPC. So I have colleagues in my team that are really going into this, so we have knowledge there. But I thought, let's write something in Java, because I think Java is a really great language.
Yeah.
And so I built the first Java library, and it's really good. You can write essentially Java code that I then compile down to C code.
You transpile it?
I transpile it kind of. So essentially what you do, for example, implement your own Linux scheduler, you implement a scheduling interface in Java. But what I then do, I have and then implement a few methods that, for example, are called whenever a task is enqueued, or whenever a CPU is like, I want to have work. And then you write code that is technically Java, and the Java compiler sees it as Java. But what I do after a Java compiler compiled it is like, oh, I'm taking this code in the compile plugin and transforming this code into C code.
Is that like, well, is it GraalVM? Is it like
No, it's not GraalVM. So essentially, I build a way in which you can write C code in Java code, but seamlessly write it into Java code. So
is it using Panama?
It's not using Panama, because essentially what I do, I allow you to write some code that's written in Java, but essentially use Java as a DSL to generate C code, and then I create the C code, I compile it, push it into a Linux kernel, and
oh wait, you're saying you give me a DSL or something that I can use to literally programmatically build up C code?
Yes.
Oh, so I'm not writing. You're not transpiling the Java code itself. You're the Java code when it runs generates.
No. I transpile the C. No, it's the thing in the middle. So what I do, I take the Java code at compile time and I transpile to C code, but I'm not transpiling any semantics. So you can't use new, for example, but I allow you to use Java, because Java is really similar to C code anyway. I allow you to write Java code that I can easily transpile to C code with ignoring the semantics, but the type system still holds. That makes it easy because you can also quite easily interact with this in user space, because with eBPF we have the C code that I generate in kernel land below, and then we have the user land. And what I essentially do is when you create, for example, a struct, and you define, for example, as a record, you can use the record both in user land and kernel land, and have, for example, global variables that you can use in both. And it's really, really easy, and it makes it possible. But people that are slightly inclined in the kernel programming and want to look into this can do this without needing to learn all the ins and outs of writing C code, because essentially when you write basic code, it's really close to your normal Java code, right? Of course, restricted.
Oh, okay. Ow. Okay, but so the resulting thing still runs in user space. That's the whole point.
The resulting, the thing is you write a program, for example, Linux scheduler, and then you have some initialization code, you have some logging code that can run in Java. And I know you're big in Spring, so what I did before was I also created a firewall where you have an API built in Spring with a little website, and that's written all in Java, runs in userland. But I then have a small part of code that's also written in Java, but I then transpile into the Linux kernel that runs in the Linux kernel, which essentially allows you to integrate your eBPF applications totally into the whole great Java ecosystem, including Spring and all.
So that's actually where I'm kind of, does the transpile, if I reference a thing from Spring that's managed by Java?
That's it's still separated. So you have to still go through the eBPF maps and global variables, but you can define types that you can use in both.
There's a way to export types.
Yeah, essentially, if you annotate a simple type, and the type, of course, has to be processable by my library, then I can, for example, have a global variable that I can read in C code, in my generated C code, and in my userland code, and I can just set a global variable to this new object, and I take care of object serialization. So for example, I know the object representation of the generated struct in C, and I wrote code that does essentially object layouting and everything, so I can push a Java object into the Linux kernel, which I find pretty cool because it allows us to write applications that are easily readable.
You know, if you had told me 25 years ago, or I guess 30 years ago this year, right? If you had told me that Java, I mean, eventually the Sun would create a Java operating system, right? There was that, and there was the stock ticker Java for Sun, and then, but if you had told me that it would be possible to get Java in like ring 0, in the kernel, I don't know if I would have ever believed you. But here we are. Life is good. Let's go.
So essentially, when I was in Linux Plumbers, big Linux conference this year, and I was introduced by someone else, so some other folks that didn't know me, with, hey, this is the guy that I told you about that does like Java and eBPF and runs Java in kernel, which I technically don't do, but it's close enough. He was like, I thought it was a joke. But the cool thing is, I then talked with one of the key developers of eBPF in Linux kernel, one of the key maintainers, and he agreed with me that it's a really good tool for education.
Yeah, that's really, really cool. And for me, I would do, so you're calling code in user space. Is that also possible?
No, that's not possible, because you still have the separation, but it's easy to share data. And it's even possible because a subset, if you write basic code, for example, code that does some arithmetic, you can write code that you can both call in userland and kernel land, which is really interesting. It's sometimes also confusing, of course, but in the end, it's really cool to write small demo applications. As I said, you can write basic Linux schedulers. You can write small firewalls, and you can all do this in a couple of lines of Java-ish code, which is pretty cool. And of course, you then it's kind of integrated in Maven, so you add the compiler plugin and you add the annotation process, and then to compile the whole stuff, I can just call Maven package, and that's fine. And it does everything. It copies in the generated eBPF bytecode into a generated class. It does enough magic. So I work now for a year in this, like one day a week, which is really a lot of work, but it pays off, hopefully.
Oh yeah, it sounds really cool. I would. So is it possible? Let me think. You've got a global variable that is shared, that's visible across both. Is there any consistency guarantees about when you update something versus my visibility of that thing in the Java side?
There is some consistency guarantees in that when you update it and when you access the global variable in the Java side, I access it, I ask the kernel, I give me the value of this variable. So yes, with consistency, it's a bit harder. These are like fields where I haven't gone into because it's not required for the demos, but yes, it will show up the next time you call the variable.
Okay, so it's initialized. There's no concurrency issues?
I hope not, but probably someone on the internet knows more. So remember, I started this whole project a year ago,
Sure.
so it's
No,
still
it's super
experimental.
cool. I'm just wondering, like, what are they? Wow, like one of the things that's interesting, and I think may not be obvious to people who are listening. It's probably obvious, but one of the things that's interesting is that some of the fastest HTTP servers in the world are built on Ring 0 in the kernel. Like the kernel can do really, really fast processing, and if you can get access to that, you can do really amazing things,
So essentially what you can write on a pretty simple firewall, like a firewall that drops every package, I don't know, coming from a big website or coming from an AI call or whatever, and can write this in code that any Java developer can read, because I implement the XTP hook interface or whatever, and drop these packages at really, really high rates because it's close to bare metal speed, and that's really cool. You can write your own firewalls directly in Java and integrate into your Java application. Of course, your Java application needs to run with root privileges, but you can then throw a Spring interface around it and then call it, and that's pretty cool.
That's what I'm talking about. I want to do that. I want to what I would want to do is write the smallest amount of code using this native transpilation thing that I could to then bubble up events to the user space.
Oh yeah, you could already do
but of course, the translation boundary from kernel to user space would be slow, and you'd be back in user space speeds. But anyway, it's still interesting. Go on.
But you can drop the packages at native speed because usually what you do, what I did with the firewall, you have to distinguish between data plane and control plane. So the data plane is the thing that needs to be fast, but the thing that decides which IP addresses to block. This could be done in the control plane. This could be slightly slower. But you do the fast thing in the kernel, and that's the whole thing that I want to do with this project. It's like I want to test the boundaries of how totally can we integrate Java and eBPF together. And it's a wild ride for you.
Yeah, so cool. That is so cool. I mean, some of the largest, like I don't know. Obviously, I'm just imagining, but I imagine, things like Cloudflare and Alchemy or whatever. They're doing this. They're not doing.
They exactly doing this. So they did even 2018. They did some research on how fast it is, and you can build really, really fast DDoS, for example, protection that drops packages from different IPs or subnets, and it works, and it's really fast. And now you can do this in kind of Java, which is awesome. And the cool thing is with this, you get, of course, syntax highlighting in your IDE. You get auto completion in your IDE. You don't get any debugging because that's hard. Because that's a whole different problem of debugging eBPF. But still, you can even write unit tests. So I have unit tests in my repository. It's called Hello eBPF. And you can use unit tests to test your eBPF application.
Wow. So for people just joining, we're talking about. Johannes here has an amazing project that he works on at SapMachine, a company in Germany, a large company.
So it's important to know that this is not a project that we're working officially on, but that's one of the side projects that I do to keep my mind busy, because we all know Josh is a nerd, I'm a nerd, and that's a project that I work on the side on. I'm working at SAP. You might have heard of a large company. Many people also know it under the short version of SAP. And we provide software to the largest companies around. But I work at SapMachine. We're the third biggest contributor to the OpenJDK. We're one of the many cool open source projects here at SAP.
And the project, this side project of yours, focuses on integrating eBPF, which is a hook for observability in the Linux kernel, and using it, wielding it, and controlling it from Java, which is super fascinating.
And the cool thing is I use it for education because eBPF is gaining more and more importance in the world. Many observability tools use it. Many of the firewall providers use it. And now I'm gaining knowledge by developing an SDK in Java for it on the side. And that was my whole goal. I need more knowledge, and how do you get knowledge in by improving the ecosystem? Because
Yeah.
I'm working on open source at work, and I'm like, growing the open source ecosystem is good, and making
so
Java more important is always
very.
good.
Oh yeah, I'm a big fan. So so. By the way, SAP. I could be speaking out of school here, but correct me if I'm wrong. I think of a few companies in the world that are like the darling company of that country. So, for example, Atlassian for Australia is a success story. You know, it's one of the. I think they were the first billionaires in Australia, for example. Just a very, very successful software company that is. Everyone has had experiences with Atlassian. You know, a lot of their stuff was very good, especially back in the early days. You know, nowadays maybe
We also use Jira all the time.
Yeah,
because it's the tool for doing Scrum.
Yeah, it's got everything. Even if you're not using Jira, maybe you're using the Bamboo or whatever. There's lots of stuff. Anyway, that's them. In Germany, I would point to SAP. I think that's like the big software company.
We're the largest. We're the largest company in Germany based on like the stock value, and we're the largest IT company in Europe. So
yeah,
it's a very large company, and we have like a small team. I belong to it of 16 people working on this, and yeah.
Change name, order, or switch places. Oh, he's not wrong. Well, I'm your humble host, Josh. You know me, so just ignore that part. It's Johannes that's important.
And I'm
here.
Johannes.
Yeah.
Hi.
So that's really, really good. I mean, I think that when you mutate the state of the native structures in C, are you using J and I? Are you using like the J long, J int?
So the idea is that, as I said, I compile the things down to C that runs in kernel space, but of course I have to communicate between like the kernel space and the user land.
Yeah.
My project is only possible, as said in the beginning, because we have Project Panama. We have the new FFI API.
Right.
So my project essentially started out as, hey, we have this cool FFI. Can I just use it to copy something on different libraries called libc, an old library in the eBPF world, which uses Python and their FFI package? Couldn't I just copy this? And that worked really well.
So you are using Panama?
I'm using Panama all the time for the communication, but not directly in kernel space. But Panama is so good.
So good.
It's
huge fan.
I couldn't have done it with JNI.
Yeah. JNI is an enigma to me.
It was good before, but I think with Panama we're having a good new stuff.
I have a theory. I think it was designed not to be good, right? Because every other language, Python, PHP, Perl, Ruby, Turtle, just everything except even C# and .NET. Every other language has had foreign function interop like Panama since day zero, right? Because they want to include the whole ecosystem so that their language looks more valuable. But Java, choosing to forge its own path, made it obtuse to integrate C so that everything would be written in Java. You'd have a Java-only universe. And it worked. You can do everything in Java now, but there's still room, there's still a need. I still sometimes want to call into the Unix or kernel, Linux kernel, or Mac OS or whatever, like COM and Windows. There's just so much valuable stuff that isn't Java that, just because it's not in Java doesn't mean it's bad. So I'm super happy to have
so part of my project is to show people what you can do with modern Java, because I think many people think of Java of like the Java 8 of olden times, which was still good. I learned this at school. It's fine, but the Java nowadays is so much better. Every time I have to write some Java 8, which I sometimes have to do, it's like, oh no, it's back in the days of my grandfather. But so this is a cool project.
You're making me feel very old. I started with Java 1.1. I was using 1.0, but I didn't. My first work was with 1.1.
I have to say you started Java pretty late. So
but you're right. Java 8 is a relic of the long forgotten past. For reference, it came out in 2014. So think about what came out in 2014. Spring Boot 1.0, early 2014, and then the Ice Bucket Challenge for ALS, 2014, right? Like, just that's 11 years. People why would you? If you were running 11-year-old Linux distro, people would look at you funny. It's not okay to use Java 8. Don't do this.
And so essentially what Hello eBPF, the project I'm working on, shows that what you can do with modern Java with just a little bit of ingenuity. And now, for example, when I now develop some tiny scheduler, which I do on the side because it's just fun, I can write tiny scheduler for testing purpose, tiny Linux schedulers just in Java because they can, and
Yeah.
don't have to use C directly, don't have to use Rust or whatever. I still like these languages, but
don't let Linus catch here of what you're doing.
I know, but if I'm honest, when I was at the Linux Plumbers conference, someone later told me that I was probably the first Java developer at this conference in ages, and he was there like for 5 years, and he found it really nice. And it was like when I came half a year ago to him, and it was like, I want to do this in Java Schedule development. He was like, what? And now he's like, that's really cool.
Yeah.
People can use this, people can try this out, and you can also try this out.
Where do people go?
I have a blog. It's mostly nerdless.de. Yeah, nerdless. Mostly nerdless, not noodless. Nerdless, yeah. It's a blog that I started a few years ago, and I'm blogging every 2 weeks on topics of profiling, debugging, eBPF, of course.
The hard stuff.
Doing cool stuff. So just read it. As I said, every 2 weeks. My last blog post came out on Tuesday on writing a Linux scheduler to do concurrency testing. Of course, I wrote it in Java. Why would I choose a different language?
Do you have blogs in Panama?
I have a few blog posts in this. There's the Hello eBPF series. I have a few blog posts also on Panama. You can find them there. You can find blog posts on object layout, on how to use Panama, where I also mention how to use error nodes in Panama. So Chain I don't have, I think, but on Panama I have a few. Just look around in my blog. They're like over 50 blog posts now. You probably find something there, because I find, as also you just do, I find giving back to the community is really, really good. And that's why we're here also.
Well, I mean, most of the time I try to give it and they're like, no, there's really no need, Josh. So you can keep it. But yeah, what you're doing is great. I appreciate that. I'm going to read your stuff. I'm going to try out the old blog and see if I can wrap my head around. I mean, I don't have access. I could use a virtual machine, I guess, but that would be a little obtuse, but whatever.
Well, you can do. So the first time you using a Mac, I think.
Yeah.
So I started developing it on a Mac too, so you can run it with a Lima configuration. And I'm hopefully coming to a conference near you. So I've been with Hello eBPF on JavaZone and DevOps Belgium. You find the videos out there to see me doing demos. Hopefully to other conferences.
This was a super interesting topic. I'm sure you'll go far. Thank you for your time, my friend. That's awesome. And thanks everybody for joining us. I have to go give a presentation in 18 minutes or so. So I need to find the room, get some water, the usual. Bye. Thanks for joining us.